Hey guys, this is Mr. Piercy, and I'm making this video as a quick tutorial for how to find the area of a regular polygon. Now on the left, there are some basic vocabulary terms that everybody needs to be familiar with. The radius of a polygon, just like the radius of a circle, will go from the center of the polygon to the vertex, because you can see that's where a circle that goes around the polygon would be located. That's where the radius would be. And we also have this part here that goes from the center of the polygon to the midpoint of one of its sides. That's called the apothem. The apothem will bisect the side of the polygon. And if we close it up here, we can see that we wind up with a little right triangle. Now that little right triangle is really important because every regular polygon that you're going to be finding the area of really is going to be found from working with a right triangle, where this is a radius, this is the apothem, and this is, I'll call it X instead of calling it S, because S is often used for side length of a regular polygon. So if we have two of those sides, maybe we don't have to do anything. We have enough information to find the apothem and perimeter. Maybe if they give you the radius and the length of the side, we can do the Pythagorean theorem to find what the apothem would be, or depending on what they gave you, maybe they only give you one of those dimensions, and then you have to use the central angle and some trigonometry to find the apothem and the side lengths. So let's say, for example, I want to find the area of this regular pentagon, and the radius is given to you to be 5 centimeters. Well, looking at the right triangle, we have the radius as 5 centimeters, meaning that is the hypotenuse of the right triangle. So I have to use some trigonometry to find the apothem and the side of the right triangle, which is labeled X, using the central angle. Well, the central angle here for any polygon is always going to be 360 degrees. 60, come on, pencil, write for me. 360 degrees divided by the number of sides, which in this case is 5. So the central angle here will be 72 degrees. Now it's important to understand that the apothem will bisect the central angle. So inside of the right triangle, half of 72 gives me 36 degrees inside that I'll be working with. So now we can find the apothem and the perimeter using some trigonometry skills. So let's find the apothem first. The apothem is the side adjacent to the angle, and we know the hypotenuse. So adjacent and hypotenuse tell me I'm going to use cosine of 36 degrees to be equal to the adjacent side, the apothem, over the hypotenuse of 5. Solving for the apothem in this case, multiply both sides by 5, and I'll get 5 times the cosine of 36. And I can leave that as an exact number. I can say 5 cosine 36 centimeters, and that's the exact apothem. Or if I needed to actually kind of understand what is that in centimeters, that is about 4.045 centimeters for an approximate number. Now the 4.045, we round it at some point when we write it out, but when we do our calculations for the area, we don't type 4.045 on our calculator. We need to save that number somewhere or use the exact number 5 cosine 36, because the only rounded number that we care about is the final area. So next we're going to find the side of the right triangle. Now if you look at the right triangle here, that side here is X. Well, I have 10 of those going around the polygon, so we keep that in mind, and we can find that, multiply that by 10 in this case to get the overall perimeter. Now the side of the right triangle that we're looking for is opposite of the angle. Opposite and hypotenuse tell me I'm going to use the sine ratio, so we'll say sine of 36 degrees is equal to the X over 5, and again I'll solve for X by multiplying 5 on both sides, and I'll get 5 times the sine of 36, and again I can say centimeters here, and that would be the exact value. If I multiply it by the 10 pieces that we have going around, I can say 10 times that, which will give me 50 sine 36 centimeters, and that would be the exact perimeter of the polygon. Or as an approximate number, if I wanted to know about how many centimeters, that would be about 29.389 centimeters for an approximate perimeter. So again, depending on what the problem is, you might have to use a Pythagorean theorem, you might have to use special right triangle rules, or in this case, we're using trigonometry to find the missing pieces of the polygon. So now we have enough information. Let's go ahead and find the area. So here, area is going to be 1/2 times the apothem, which is 5 cosine 36, or if you saved that 4.045 number on your calculator, you would just recall it here. And here we'll say 50 sine 36, or if you saved that number on your calculator, you can recall it at that point here. Well, you type all of that into your calculator, and here we're going to get an area of about 59.441 centimeters squared, and this is where this is the only rounded number that we really care about, and that is the area of the polygon. So the only other case that you might want to really pay attention to is that for regular hexagons are very, very popular for areas of regular polygons because those use 30, 60, 90 special right triangle rules and can be evaluated relatively quickly if you remember what those rules are. But that's it for this video on how to find the area of a regular polygon. If you have any questions, come see me in tutoring at school, or shoot me an email and I'll be happy to help you with whatever questions you have. But until next time, guys, thanks for watching and take care.